Okay, starting the clock. What I've done with question 3 is to save time by calculating the frequency densities in each part, A and B, and plotting both the histograms. And well, obviously you know how to do a histogram now. It's really part C I want to focus on. But just to reiterate, how do we work out a frequency density? We take the frequency divided by the width of 20. 3 over 20 was 0.15. And there's the bar there for 0.15. Here it's a 0.2 really. I can't get any more accurate than that. The next one, 11 divided by a width of 10, 1.1. 35 divided by a width of 5, 7. And so I carry on all the way down the table of data and plot the histogram appropriately. Look how skinny that one is down there. 4 divided by 50 is 0.08. The best I can do is to show it as 0.1. And but at least you appreciate the different class widths and the different heights, and just to see how weird the whole thing looks when you've got different class widths. And I've done the same for part B, speed. So 25 divided by 5 is 5, 35 divided by 5 is 7, etc. And so I've got the histogram next door for the speed. If you let me do it, there it is. Oops, gone too far. That's that one there. Again, frequency density along the y-axis, and the speed along the x-axis, the continuous variable. And these are the bars I created earlier before I clicked on the video. It's really about part C, and I'm going to take my time with this one. This is quite tricky. For each histogram, estimate the median of the distribution. Well, the median is the value in which the middle thing or the middle person, whether these are people or not, I don't know. We're looking for the middle value essentially. So we're looking for the value of the 40th thing, so the median time in the first instance. So looking at A, so far if I add all this up it comes to 80, I believe. Let's check it. 3 plus 11, 35 plus 27 plus 4, that should come to 80. Let's just check it. 14 plus 35 plus 27 plus the 4, yeah, we've got 80. So I'm looking for the 40th time, alright, in which what is the 40th time, the median time. Let's do it now. Now, first two bars give me a total frequency of 14, plus another 35 takes me up to 49. Therefore, my 40th bar has got to be within this third class here. So let me just draw what that bar looks like. So again, I'm exaggerating for the effect. I know this bar has a frequency density of 7, so I'm going to put a 7 up the side of the bar there and call it the height of 7. I know the bar width goes from 30 up to 35. Again, it's just a blown up version of that thing there. It's obviously not to scale, whereas that is totally accurate. Now I have got, let's reiterate. Okay, now to find the 40th time, I know so far I've got 3 plus 11 plus 35. That takes me up to 49. To find the 40th person, these 14 are taken care of already in the previous two bars, that one and that one. I need to work out how much of this third bar will house the 40th person in order to work back and find the median time. So here I go. 40 take away these 14 items leaves me with 26. Therefore, since 26 is the frequency that I'm looking for, change to red, so this area is 26. So what width, call it x, what width do I multiply the 7 by to get 26? Little equation there. 7 times my width is 26, so my width is going to be 26 over 7. What's that going to be? So 26 divided by 7, that gives me 3.7. Is that alright? Therefore, if the width is 3.7, then the 40th, the median speed is going to be 30 plus that extra 3.7, which gives me 33.7 hours. And as you can see, that very clearly fits in within the 30 to 35 bar, so we know we got it right. Okay, that's quite complicated, isn't it? Let me try and do the next one. I should have started that video ages ago. Let's try and do the next one. Well, that's the frequency distribution shown as a histogram. If I can just copy this perhaps, maybe take it next door, then we've got something to look at, haven't we? Paste it there. Right. Paste this about there, I think. That's the one I want, just here, this bottom one here. If I can put the FDs with them, that's going to help. I've got 576. Write it in. I've got 576. I also had 1.5 and 0.4. Okay, and that's the frequency densities for the distribution showing speeds, and I've got to work out the median for that. Well, alright then, altogether I have 25 plus 35 plus 42 plus 16 plus 6, not 16, it's 12, isn't it? Rub it out. 12 plus 6. We have got 25, 35, 42, 12 and 6. We have 120. Therefore I'm looking for the 60th speed, as opposed to before it was whatever it was, I can't remember, let's just look at it. Yeah, it was the 40th time, so now I want the 60th speed. So 60 then, that is 50 and 60. Well, that's a very uninspiring question, because the 60th speed is right up against this bar here. So the 60th speed is 65 miles per hour. It's right up against it, isn't it? So 65 mph. That was very, very easy. I'm quite disappointed with that, to be truthful. Let's check that again. 25 plus 35 gives me the 60th speed, and the 60th speed finishes exactly at the upper boundary, at the upper bound of this class interval. Therefore, you're looking at 65 miles per hour being the median.